Hello, everybody. Thanks for holding out with us today. I'm going to be introducing our next speaker, which is Dr. Elizabeth Petrie. She's the Moncrief Chair in Petroleum Geology and Professor of Geology at Western Colorado University. She has a bachelor's of sciences in both geology and biology from the University of New Mexico, and both a master's degree and PhD in geology from Utah State University. She has also worked as a petroleum geologist for 7 years. Dr. Petrie studies deformation of the Earth's crust and how this deformation influences and is influenced by the movement of liquids in the subsurface. Her research combines quantitative observation from outcrop, laboratory experiments, and subsurface data sets to understand the formation and distribution of fractures and fault zones, and the role of variations in rock mechanical properties have on failure across many scales of observation. Dr. Petrie's research is applicable to a variety of topics, including the understanding of earthquake processes, the distribution of energy and mineral resources, and the subsurface storage of carbon dioxide and other waste materials. Since 2014, Dr. Petrie has been a professor at Western Colorado University, where she actively involves undergraduate students in research projects that focus on structural geology, rock mechanics, and fracture development. Dr. Petrie utilized Slido to collect audience questions throughout the panel's discussions, so please utilize that app to submit your questions for her. Without further ado, please welcome Dr. Elizabeth Petrie to our technology panel.
Thanks, Veronica. I went to fill my water bottle because I thought we had a break. But thank you all for staying. I know we're the last session. That's great. And we just had a time change, so it may actually feel either earlier or later than it actually is. For me, it feels a bit later. Today's panel, I'd like to welcome up on stage with me, Dr. Malcolm Ross, who's a strategic advisor at Eavor Technologies and adjunct faculty and lecturer at Rice University. Dr. Xerxes Steirer, who is a research associate professor at Colorado School of Mines. He serves on he's chair of the sustainability board, the city of Edgewater, and owner of Just Heat Pumps, as well as Sarah Derdowski, who is the Wells Fargo Innovation Incubator program manager at the National Renewable Energy Laboratory. So to kick us off, I'm going to sit down, but I would ask each of the panelists to take a few moments to introduce themselves. I have a clicker here. I was instructed only use the arrows. I think the order of your introduction is Malcolm Xerxes, sir.
Much. Yes, good afternoon, everyone. Yes, I am Malcolm Ross. I wear many hats, and so I actually brought a prop here to sort of symbolize that. Yes, indeed, I am a faculty member at Rice University in Houston. So I teach a geothermal class and a GIS class there. I also help startups. So I do investing and kind of, the venture capital kind of thing for several startups. I also do lobbying. So I have a tie that I can put on here at the federal and state level for geothermal. And then I also am a strategic advisor for this company called Eavor, for which I have a hat of that one as well. So the point is I wear many hats, and overall I categorize my work as being a geothermal evangelist. So my expertise, I was the subject matter expert for geothermal energy at Shell, and I have subsurface expertise. And I wanted to, when I left Shell, I wanted to try and raise the tide for all boats in the geothermal space. And so I gave myself this title of geothermal evangelist because previously my title at Shell was Black Swan Detector. And that was probably worth explaining. I worked in the innovation organization, and my job was to identify startups that had revolutionary ideas that I thought would make a big impact. So I helped to identify small modular nuclear reactors and several other opportunities for Shell. And it's Black Swan because this concept comes from Professor Nassim Nicholas Taleb, of which The idea of a black swan is that it is a huge dramatic thing that no one predicted, that once it happened, everyone said, oh, well, that was obvious, right? And so COVID is an example of a black swan. I was looking for black swan companies. And so one of the black swan companies I found is this company called Eavor, which I will wear my hat to talk about Eavor mostly here. Eavor is doing closed loop geothermal. That was the revolution. This is not your father's kind of geothermal. This is a new way of doing geothermal that tends to avoid many of the challenges associated previously with geothermal. This is their first experiment, which they conducted in 2019. So this is not particularly new, but they're applying many of the traditional oil and gas technologies and reapplying them to geothermal. What they're doing here is drilling 2 wells, almost 5 kilometers apart, going horizontal and making those wells meet end to end, 8-inch well, end to end successfully twice. And that made it possible for them to do closed loops. This is what it looks like. This is what it has evolved to now. These are multilateral wells drilled from the same pad, and they drilled 2 vertical wells down, and then they branch out like a fork, 2 forks, and they connect at the end of that fork. Sorry. The first commercial project for this has just been started in Geretsried, Germany. The 2 largest land rigs in Europe right now are sitting side by side, drilling these 2 vertical wells. And they will be producing power and electricity to one of the towns south of Munich. So this is one of those I believe to be one of those disruptive technologies, because you're not looking for anything but heat in the subsurface. And so you can go almost anywhere because it always gets hot beneath our feet. And if it's not quite hot enough, just drill further down. So that's a little bit about Eavor, and there's a comparison table here about the differences between Eavor, this closed loop technology, and this open loop technology. No seismicity, no bad chemicals brought to the surface, no induced seismicity, I think I mentioned, and so on. So there's lots of stuff going on here, but how they got here is kind of an interesting process. And so I'll be ready to talk about that as we move forward. But I just wanted to give a little bit of background in that technology.
Thank you. I first have to really thank Jessica for inviting me here, and also thank Liz for being so organized and pulling all this together, and Western for hosting this inaugural event. But most of all, I really want to thank the students. I want to thank the students for demanding sustainability of their organization, of the institution, and more energy education offerings. I've seen that narrative happening at the Colorado School of Mines, and it's working, getting traction and starting to gain momentum. So nice work. I work at the Colorado School of Mines. Several of us about 6 years ago thought it was a good idea and put a lot of effort into developing a shared research facility. A year and a half ago, we piloted that, and now it is open access. So I just have to point out that we have amazing facilities available for your research needs. We service the whole Front Range. A lot of companies come and use our equipment for material science, research, engineering goals. So if you have innovative ideas, tech ideas, just, we're here for you. And it's been really, really amazingly positive overall. I tend to manage most of the X-ray equipment. So if you have specific questions about X-rays. We have the Advanced Energy Systems Graduate Program, which is Mines NREL, National Renewable Energy Lab, a collaborative kind of enterprise where a mines student in this graduate program can be placed in a research group and with particular goals at the National Renewable Energy Lab. And I love that this has been formalized, because when I went to mines about 15 years ago, more than 15 years ago, it was informal, and you really had to kind of jockey your way into NREL. So this is actually a really amazing program. Everything from the business and buildings to grid scale renewables. We have several institutes at Mines that are functioning towards this transition goal for our energy ecosystem. One of those is the Payne Institute for Public Policy. This institute right now is heavily focused on minerals. And we heard from Ron earlier, and fantastic points there. We also have the Global Energy Futures Initiative. This one is currently heavily vested in oil and gas, decarbonization of midstream and upstream exploration and production. I recently took over as co-director of our energy minor program, where we have multiple tracks for students, and I'm super jealous of how much interest and excitement you have for the energy program here at Western. Yeah, so a couple of things that are front and center on my plate, innovation tech-wise right now, are zinc water batteries. And we heard from Drew about iron air batteries, which is a fantastic invention. Just a quick summary of those batteries. They kind of originated out of an ARPA-E project where University of Southern California developed that with about a $1.5 million kind of funding investment. MIT Incubator startup kind of picked that technology up and spun out form to create these kind of batteries. And I like to put batteries for grid scale power in like kind of an analogy of a water bottle. So there's two different things that are important about batteries. One is how much energy it can store, and two is how fast it can deliver that energy, like the power rating. And the analogy I have is the water bottle. So if you have a really large water bottle, you can think of it like a battery that has a lot of energy in it. But what if you had like a tiny coffee straw, right? And you're so thirsty and it takes you like an hour to get a sip? So that's the power draw, right? You can have a lot of energy in there, but you also need to deliver power instantaneously. Say if you had a grid event where you lost one or two generation stations. So zinc water batteries have high power delivery capabilities, and I'm pretty excited to be working in that technology. The heat exchangers for heat pumps. This was so exciting for me because I had done so much fundamental work in material science, and a few years ago transitioned to work more with companies on projects for really action-oriented deployment and innovation in the tech space. And so I went from students not really wanting to work on my projects to students kind of lining up, and I didn't have enough work for them. So these are 3D printed heat exchangers where we're looking to increase power density by 3 to 10x for heat pumps, in particular air to liquid heat exchangers. So you can imagine a heat pump heats your home, and you might have it at 1/5 the size of our current heat pumps. And then personal story here. I transitioned my home to heat pumps, and I don't think of myself as a victim, but it didn't go well, right? And that company went out of business by the time the heat pump broke 2 years later. And I went through 4 companies trying to find anyone who knew what they were doing on how to repair, diagnose, would even want to look at it, and didn't find anybody who could service and repair my heat pump. So I turned my aggression or my anger into productive power and created a heat pump company. I bought all the tools. I taught myself everything. I got certified by the EPA to handle refrigerants. I've gone through like 4 certifications now. And this company helps people avoid the challenges and problems of changing over to heat pumps that I encountered and that I see across the Front Range. So if you have any questions and just want help, if you want me to review the bid from your HVAC contractor, that's where I really like to help people kind of succeed on their journey. And I'm a big fan of history. And this is, let's see, the last 1,000 1,000 years of carbon dioxide, you know, equilibrium levels in our atmosphere. And just shout out what I put a big red arrow right around 1979-ish. Does anyone know what major invention kind of catalyzed the accelerating up curve in CO2 accumulation? Steam engine. Thank you. James Watt invented the efficient steam engine. This will bring me back to efficiency, but right. So what a great invention. And now we're at the tip of this curve, you know, over 420 ppm, and we're wondering, hey, how do we turn this curve flat or around? And so this is kind of a historical context that we weren't always here, but we are here now. And so this is also innovation, right? This was a major innovation and with major implication. And then finally, I bring it home to today. This was 2022 planned grid additions in terms of the diversity of power from the Energy Information Agency. And the one thing that I see on here is that there's no coal addition plan, right? And that was at first glance, I thought this was okay. This is progress. And then you look into the coal production for the United States, and it's up year over year as of September 2023. And so even though we're not building out additional coal-fired power plants, we are producing more coal, and that's going to places where they will burn coal. And so that's just kind of food for thought and kind of important context for our current scenario. Thank you.
Thanks, Xerxes. And the heat pump thing we can talk about later, because that's a huge piece of what we're working on at NREL. But afternoon, thanks for hanging in there, guys. I'm Sarah Derdowski. I work at NREL, National Renewable Energy Lab. And I specifically work in the Innovation and Entrepreneurship Center there. I'll go into a little bit more detail as to exactly what that is. I didn't have hats or anything, but I did have a couple giveaways because I feel like it's the afternoon, guys, and somebody needs to win a prize. So that being said, it's a shout out situation. Does anybody know how many national labs there are? Like Price is Right rules. Yeah, just shout it out. Go. No. Good. Keep going. Some more. No. More. Less. No. Lower. Yes. Winner. Lady gets a lovely NREL gift here at the end. See me at the end. Yeah, there's 17 national labs. NREL is just one of them, and we're located in Golden, Colorado, which is also where I live. And so one of the things I love about Golden is it feels a little bit one step removed from the city, which is great. And we're right close to Colorado School of Mines as well, who we collaborate with pretty heavily there. That being said, I'm really thankful to be here today. I'm thankful to be out of Denver, out of Colorado, and in a little bit more rural community. I think some of the projects we work on at NREL do affect a lot of that. And a lot of the projects I specifically work on now are in the built environment ag. And so it's nice to come out here to actually be a part of the communities and organizations that are focused on that. A little bit about myself. I think it's important. I used to work at a university and stuff as well, to acknowledge the students, Xerxes, just like you did, and want to give you a little bit of my journey and the circuitous path that it took me to get to NREL and to work in innovations. And so I majored in international relations and economics. I was going to save the world. So went and did that, worked for the UN in Sarajevo for a little bit. And I had an experience, I think, similar to what Kayla was talking about this morning, which was I felt like we were going to places and telling them how to do things, going to communities and telling them how to fix things when they didn't live and work and really know what was going on in those communities. Didn't sit well with me. And so then I thought, I'll go work for the Canadian government. They generally have their head on straight. When I worked for them, their kind of diplomacy was energy and environment. That were their top two priorities. While I was there the next couple of years, it changed to environment and energy as they started to change and shift into what they wanted to focus on. Helped me think a little bit more as to what I wanted to do and what types of projects. We worked a lot on oil and beef because that was what our trade was. Then hydroelectricity, things started to shift and change. Then I jumped over to CU. I ran their energy center there. And so I am very passionate about workforce and what it means. And so hearing heat pumps as an issue, workforce is an issue in energy. You've heard Sarah Sandberg talk about top talent. Companies can't keep talent because they want to keep focused on what they are. And it's true, there's a lot of opportunity there, but there's opportunity across the value chain of labor. We look at folks who are installing heat pumps. The issue is not the heat pump. You can't get anybody to install it because we don't have workforce trained to do it. We don't have companies who are set up to be able to use the technology that has been innovated, right? So we have these great things, but we can't use them. That's a big problem. Or we don't have people who can actually install them. So that's an issue. And then as far as workforce and workforce education, I mean, that means for like, how do you uptake tech, right? So you've created these things, large company, how do you actually uptake it and use it? Because there's a lot of things that we've come up with in the lab, outside of the lab, that we just can't actually implement. And that last piece, deployment, is a huge issue. And that's really kind of what we're facing right now in innovation. At least my daily job is. And then CU did a lot on the workforce side, focused on that. And then I jumped over to private investment. It's an opportunity for me to see what the private side was, as opposed for working for governments for years and different pace, different levels of bureaucracy. Went and worked in a private investment company in real estate for a little bit. Gave me a different perspective on what business is thinking and why they would not use tech or innovate. And then realized it's super interesting for me, but I really want to work on making impact with companies and seeing them be successful. And so then I made the jump over here to NREL. New to NREL as an employee, but not new to the energy space, obviously. And so I've actually been with this group only 9 weeks, so not too long, but I've known them for a really long time and worked with them in a number of ways. So I'm super excited to be part of the innovation and entrepreneurship group here, where they really kind of focus on being great conveners and collaborators. And I think Jess talked about collaborative leadership this morning, and that's really a big piece of what we like to be as the national lab, is leading and collaborating with industry. And so there's the answer to my trivia question, 17 national labs. You can see where the rest of them are located. Something you should know about me. I am secretly a huge nuclear fan, always have been. You can ask anyone that knows me, they know it's true. I'll be the first one to advocate for it and always have been. So that's Idaho National Labs. Excel here, they're doing huge work with Idaho National Labs on SMRs and a variety of other things. If you're interested in that, check it out. It's pretty interesting. I think it's important to mention, we are the smallest national lab. We've only been around about 47 years, but we have about 3,700 employees, but we have the most partnerships of any national lab. And I think that's really important. We're only one of 3 national labs where we have a mandate to apply our research, which means we are mandated to get our research out of the lab and into the market. So that's why we're so motivated and have so many partnerships. Here's 4 kind of big bucket areas of where we work. We do not just work on wind and solar, not at all. That is just 2 small things in which we work on. And these may look pretty siloed, but they're not. So even on our mobility, we talk about how that works with grid integration, how that works with buildings. Can you plug your car into the building and have the building power your car, or vice versa, or all sorts of things. So we do all of that, but just gives you kind of an indication of where we're focused and what we work on the renewable space. And this is my group. We like to say we're the front door to NREL. So that's me. That's kind of what we work on there. And so this is our group. And you can see kind of our motto, but we really kind of want to bring ecosystems together and kind of transform this space. Want to talk too much on it. So this is kind of a classic slide, I would say, on when it comes to innovation and what happens. So there's lots of valleys of death. And I'm sure if you talk about innovation and technology, people talk about it. So where we're really getting stuck is on this demonstration to deployment. So we spend a lot of time in the lab with all the programs that we have on research and development, prototyping, kind of working out some demonstrations, but it's this last valley that is the most challenging. And this is the last valley of death where, people get stuck, where most startups go to die. That sounds awful. But it's true. This is a huge issue. And so big piece of what DOE is working on, what national labs are working on, is deployment of technology. What are those last barriers that we're working on? And so That's a big piece of why I came in. So I'm working on what's called scalable tech now. So I run the IN2 Innovation Incubator. It's sponsored by Wells Fargo. That's one of our kind of our partnership programs. And it's to say, how do we get more technology over that last hump and through to full commercialization and deployment? We believe you have to accelerate the timeline. There's a lot of one-to-one matching when it comes to, let's take one technology to one company and see if it works. And so we're looking to accelerate that by doing a many-to-many. We do this in lots of ways. These are all of our partners, different ecosystems that we work with. One way that we try to accelerate things is through our channel partner network. Xerxes mentioned the MIT group, InGen. There's so many other accelerators out there. What we have done is curated all of them together. They're part of our channel partner network. So anytime we're looking to innovate, we kind of send the call out through our one channel, who they then get to all of their different channels. So it's been a great partnership. We're able to do that because we provide them money to do it. And so they pay attention when we say something. And so it's been a great way, though, to accelerate and get change out there. These are where a lot of the accelerators are located. Again, we try to make it as diverse as possible, different communities. Alaska is a big one for us. I just met with the Elemental Accelerator when I was out in California. I'll be meeting with, we just got Georgia Tech online. So we try to span and make our reach outside of just Colorado, although we do work heavily with our local partners. If you're interested and curious, I won't go through many more of our slides, but essentially these are a few of them. I run this project here, the IN2, but many of our other partners, like our GCXN, which is a Shell sponsored one, is modeled off of this IN2 program. We've seen so much success. Basically, we have raised over $2 billion of follow-on funding for any of our startups who have come through. That's fantastic. We have great partnerships with our investors, a massive investor forum every year. Innovation is here and it's exciting. And as much as people talk about not as much investment in clean tech, there's still a ton of investment in clean tech. So, yep, I think I just had these slides that show kind of like where stages are of our different accelerator programs, and more information there. So really, yeah, feel free to reach out to me. The last thing I'll say is I do wear a couple hats. That's my NREL hat. I wear a grid hat as well. I sit on a board of a grid looking at the Western grid. So a lot of the topics and conversations going on there. And then I also sit on several women's boards when it comes to women in energy. So if you're looking for an advocate in the space or a friend in the space, if you're a woman in this group, definitely reach out to me.
Okay, well, thank you all very much. I feel like today's been a big, lots of moving parts going on in the transition from communities to different technologies to how we get our energy. If you guys could tell us a bit about some of your organization's technologies, how we're going to get to net zero, maybe what the most promising technology you think is out there. I don't think there's one answer, and there's probably many scales of deployment, but what do you think holds the most promise?
So what's the most promising tech? Oh, good question. I know. Well, it depends, so since I've swapped over to IN2, we've been focused on buildings and ag tech. And so I would say buildings. I mean, you look at the emitters out there outside of transportation, buildings are some of your number one emitters. And what I've been talking to investors a lot about, and they're really kind of focused on the material side of buildings. I think they are really looking from the buildings from the ground up. And so they've really been interested in both like sustainable concrete. I'm sure you've heard a lot about that. They're really looking at materials and how they can decarbonize those, but not just decarbonize, have a lot more companies be able to do that to bring the price down so that more and more developers can be incentivized to use them. So I think it's looking across the value chain of buildings is huge. And then another piece we're kind of looking at quite heavily is critical minerals. The big piece that we're looking to stand up both at NREL at the lab, kind of new research on that. And we're doing a ton of new research in the lab on hydrogen. I can't speak to that project since I'm still new on it. I've read the headlines like you all, but still kind of looking to see what that looks like. I can give a lot of examples of really interesting new tech that I've seen in the lab. An example of an ag tech one, which is pretty fascinating. Wave of the future is everyone talks about precision agriculture. It's always been kind of a dream, but I'm literally seeing it happen as it starts to come out of the lab and go into field trials, which is just amazing. Some of them take old technologies and just tweak them and make them work well. So putting fluorescence within plants, that's not new, kind of changing the technology or the DNA of the plant. But when you're doing it so you can detect it in sunlight, when you're doing it in your partnership with John Deere, where you can just get it done and it's just a new tweak on your tractor, that's amazing, where you can pluck out a plant in the daylight and say that one's diseased, that one's distressed, that one's having issues. Just as you go about your normal day, that changes what you're able to do. It changes how much water you're using. It changes how much energy you're putting in fertilizers in the soil. So these are just like brand new ones, which are fascinating. But a lot of them are tweaks on current technologies that we have, or bundling technologies that we have together to make it innovative in how you use it.
Yeah, I'll leave geothermal for you. Oh my gosh, especially with all the incentives. So I worked in solar for R&D for a really long time, and I still think that the massive deployment of solar that we're seeing right now is helping a lot. That said, this storage component of sulfur or of solar actually makes it work, makes it more valuable, because the sun shines during the day and you have to provide electrons at night. And so balancing that load and demand throughout the day and night is critical. So those are key things. At mines, we've massively installed solar over the last few years, and that's helped reduce our energy footprint by almost 80% in terms of carbon neutrality, which is fantastic. So you can do these things at scale quickly with organizations that have decision-making power and the ability to finance those projects. I think kind of we're right now experiencing two major innovations. One is the fracking, right? We see a lot more natural gas, and that really changed the conversation around natural gas in the US. So it's become, hey, we have plenty of it. Let's use it as a transition towards, carbon reduction, 40% carbon reduction over coal. And then also a lithium-ion battery. The lithium-ion battery has invigorated discussions around storage to just like an order of magnitude, right? I mean, these things are actually pretty dangerous in terms of like we have them in our pockets, and it's not hard to find a video of a phone catching fire on a bus, from some camera just catching it. So it's amazing that we're deploying these at scale, because we need that storage so much. There was a comment about pumped hydro storage, and pumped hydro storage has been for many decades the majority of US electricity storage. But that's 95% of our storage in 2013. But now battery storage on the grid is approaching half of all of our electricity storage. It's being adopted very quickly and in a variety of forms. So I think that's going to be a big piece towards the decarbonization component. I do want to add one more point, which is this and rather than or. So as we adopt all of the new generation technologies, when we look at our grid breakdown, our power portfolio mix for the United States, it really is adding capacity that's renewable. We're not yet really reducing fossil fuel generating capacity in any significant way. And it's a little bit troubling to think about that if we are to achieve goals of carbon emission reductions. So it's this kind of balancing act as we bring on clean energy technologies. How do we balance out the phasing out in an equitable way of older fossil generating technology?
Are probably expecting me to dive right into geothermal, and I will, but I actually want to go in a different direction first. A lot of the time I see people getting two things kind of mixed up. And one, I think, is the going forward, we want to reduce the amount of carbon that we're producing. We're just talking about it, right? In fact, we've added a lot of renewable energy, but we really haven't reduced the amount, our CO2 footprint, other than to basically replace coal output with natural gas. Okay, and that's less CO2. But the reality is that Xerxes showed that scary graph, that exponential growth of CO2 in the atmosphere. That's already in the atmosphere. That we're not doing anything about that, right? That's the really big challenge, right? And how did we get there? We got there because chronically, I believe, that the world is addicted to finding the cheapest way to do things and not willing to pay the full life cycle cost of whatever it is, right? So in coal, you know, we were burning coal like mad, but we weren't even aware that we needed to get it out of the atmosphere, right? And then we began to do point capture and so on. Nuclear, right? Oh, we all love nuclear, but we really don't know how and who's going to pay for getting rid of the nuclear energy. And the same thing with all the fossil fuels and so on. So I think one of the biggest problems we face is solving the CO2 in the atmosphere problem, right? And getting that out. And this is direct air capture, what I'm really talking about, and storage, by the way. That's also a separate problem. But direct air capture of CO2 is something we're going to have to figure out. And it is a very, very difficult thermodynamic problem. And so I think that's an area where we need to focus. And I'll bring it to geothermal. One of the common direct air capture modes uses huge fans, and it feeds it through an absorption system that grabs the CO2 and feeds clean air out the other side. But to run those fans takes a lot of electricity, and then to clean that absorption material and to gather that CO2 out of that absorption material takes heat. Guess what? If you could pair geothermal with that, you could do that essentially without adding any more carbon. If you look at doing that direct air capture from the grid, you put about 90 to 95% as much carbon as you're capturing, you're putting back into the atmosphere because you're using power from the grid, and the grid has a CO2 footprint. So that's just one of the examples of where geothermal will work. I also wanted to talk a little bit about other opportunities with geothermal. So everyone thinks about electricity, and that's great, but that's a legacy of the fact that geothermal, your father's geothermal was wherever there was hot water bubbling under the ground. It was the Jed Clampett School of Exploration for geothermal. Wherever there was hot water coming out of the ground, that's where we're going to put a plant. And then if that was far from your community that needed the power, you needed to make it into electricity and put it on the grid. With this geothermal anywhere thing I'm talking about, if we could put the geothermal plant close to the demand site, then you could use the geothermal energy directly. You could use the heat directly. And that's far more efficient because converting heat to electricity probably at best is a 15 to 20%. You pay an 80% to 85% penalty in converting it to electricity. And if you're going to use that to convert it back to heat, you're paying the penalty twice. So I think the big advantages in geothermal is actually direct use and using the heat in industrial processes, in homes, in heating the Katie building here, the computer science school. That's a perfect example of that. But there's also, and I come from Houston and I'm like, who cares, right? Heating. Well, you can do an absorption chiller, which produces cool from heat. And I don't go into get into the thermodynamics of that, but that's a huge opportunity as well. The last element of geothermal that I want to point out is the brine that you produce from your more traditional geothermal often contains valuable things in it, including lithium. So the majority of lithium in the sort of projected future use of lithium comes domestically from Salton Sea and from the Gulf of Mexico. There are substantial resources there. And I think that's another example where geothermal doesn't just do one thing like solar and wind and batteries. They just produce electrons. with geothermal, you can do some heating in the winter, do some cooling in the summer, make some electricity, and do beer brewing, use the heat for beer brewing, and so on. So you can cascade geothermal and have a positive impact on a whole set of opportunities, and generate revenue from all of those things from just one source. So I think geothermal is the most underappreciated renewable energy source on the planet.
All right, well, thanks.
Oh, Thank you.
So I think this I'm gonna use this question to lead into the next question, which, so this one I think speaks a bit to how communities can get involved and changes you can make locally. So what issues are there to be aware of when you're converting from a natural gas heating system to a straight heat pump system at a large scale? So if Western wanted to go heat pump, or maybe some solar, what are our troubles?
So on the local scale, I really work with municipalities, right? And I've had the pleasure of implementing an energy action plan in partnership with Excel Energy and our local government. And that was fantastic. And it ramped up and motivated us to do an electric vehicle action plan, which we finished the planning for and are now implementing. So local governments have kind of the final say, right? And this is pretty incredibly powerful and necessary for everybody to really pay attention to what's going on locally. I love hearing the stories about what's going on in Gunnison, and it's inspiring. And in some communities, it's not so inspiring in terms of kind of the scarcity mindset, when we would just want to stick with what we know. So about 6-7 years ago, some friends and I approached our city government saying, hey, we want to be a DOE Soul Smart city. This is great. It's going to be, a series of questions and check boxes, and we'll get stamped Soul Smart. And our city government really pushed back. They said, no, they were not into that at all. They were not entertaining that. On the other side, we are a tree city. So we plant a tree every year to maintain that status. But it was amazing to see the pushback. And we didn't know why. The why was that in the cooler conversations that were happening in the back rooms were that this is a money play. Somebody's going to be profiting off of this. We don't want this in our town. And no, thank you. So my friend ran for mayor. He was elected mayor, so things started to change, and helped build up our sustainability plan, which my wife helped lead the writing of, and we built SMART goals into that, and just saw that that resistance break down when you really lean into the government, right? Instead of an outsider screaming, hey, just do it better. You have to kind of step in to the ring and start to have those difficult conversations and debates with folks. And so today we just reviewed our sustainability plan and we're 80% done. We have this great community. We're making progress in every area. And it's just amazing progress when you have kind of the right people on the bus and it's going in a good direction. And so that's kind of how I think about local communities operating. When I think about other communities that are starting to push back on wind energy and solar energy developments, it's just happening at the local level. The town board, the city governments are changing zoning to basically prevent these types of facilities from being built in their communities. And that's going to be a challenge going forward. So I encourage everyone to kind of definitely vote, but also kind of interact and communicate with your local leadership.
I think Xerxes made some great points, and I think at NREL we do have tons of programs, slope programs, state and local. We work with tribal groups, C2C, which is community to community. There's lots of different programs, so we're actively trying to reach out to communities to better understand what their needs are, how they can participate, how they can say what they want, what they need. And one of the things specifically, Xerxes, that you brought up, which is being active. So we have a couple of research projects going on now. One specifically is looking at diffused innovation theory. And so basically talking about why it's so hard to uptake innovation. And so thinking about that from a local community standpoint too, not just companies. So states and local municipalities, and what are their barriers to kind of being able to do this. And some of it is so layered. You do have that local, then you have that state, you might even have that county. And so they might not know what's out there, and they might not know the risk behind uptaking some new innovations and technologies that we think are just common knowledge, and you should be able to do it, and nobody's going to get any extra money. It's, you can even get money for these things, but there's, I don't want to say a lack of education, but it's trust too. And you heard us talking about trust building and things like that. So go and participate. I would say, like, don't be a naysayer, be open to discussion about it. Doesn't mean you have to agree, but go and learn about it. And then go and participate, because some of the programming we're rolling out at NREL will be about that, be about bringing people together to better understand what's available, what the risks actually are, and what the opportunities could be. We don't say you should or shouldn't. We don't say you should take our technologies or not take our technologies, but you should be aware of what's out there, because lots of these communities end up being laggards when they could have the potential to be leaders of taking innovation, because they don't have as much red tape. They don't have as many layers of approval or pathways that need to kind of get built in. You might only have like 2 or 3 people on city council that need to say yes, and that can happen, and you can start to innovate. You can start to make your own choices about your carbon footprint, your sustainability of that organization or of your community. So participate.
We have about 15 minutes left, but so I have a question about geothermal from the audience. When geothermal uses fracking technology, what is the water footprint of the project, and is that water returned to its source?
So I focus on the closed loop, specifically to avoid focusing on the EGS, enhanced geothermal, and the fracking systems, because I think that's going to be make it very difficult to push that technology out in the rest of the world. Sure, we can frack in a lot of places in the US, but in a lot of places, even in the US, and you can't frack. My knowledge of it is limited, but I do know that the what they call stimulation is it has a smaller water footprint than you would in a oil and gas frac.
In the closed loop technology, how quickly are you depleting heat from the reservoir, and is that a detriment to your process?
Yes. So that first figure I showed you with just the 2 lines, that very first experiment, this was the second question that they needed to prove, was this thermodynamic question, and how fast does the heat deplete? It comes down to how fast the water is flowing through the pipe, because that water is moving that heat. And in the end, they proved that these kinds of projects can have nearly infinite lifetime, as long as the water's not moving too quickly, because the heat does get replaced, just not very quickly. And so the reason they went to that multilateral, the fork in the ground thing, was that for every multilateral, you can divide by that number. So if you have 6 multilaterals and 1 main pipe, the flow rate through the multilaterals is 1/6 the flow rate through the main pipe, because you're splitting that flow over 6 pipes instead of 1 big pipe. That means the flow rate is much slower. And so that's what makes the lifetime last. And there's been numerous studies now showing that that these things do have the ability, the heat extraction is not too fast.
Everyone, maybe regarding nuclear, will the US start leaning toward using nuclear energy to meet Paris Agreement goals, considering our current heavy reliance on fossil fuels for electricity?
And I can tell you what I think or what I want to have happen. That's a tough question. Since I came in energy, which is essentially in '08, when I really started working in this space, I remember I was in DC. We were meeting with FERC, which was super exciting. We're having dinner with them in DC. And Fukushima happened. Literally, while the FERC guy was presenting to us, and he was like, "I have to go." I was like, "Yes, you do." And so, it had been a renaissance of nuclear before that. People were excited about it. Getting more on board with it. Kind of went out of style there after that tragedy happened. But I would say in the past, like 3 years or so, we're starting to see that renaissance again. We're starting to see private investment go into it. I mean, sure, everyone knows about Bill Gates' investment into it. We've had tons more interest in it. Idaho National Labs has been actively working hard on it. I think there's been a generational shift as well as the perspective of what nuclear looks like. I think boomer generation had a different experience with nuclear and what that meant. I think millennials and Gen Zers have a different perspective. I think we face different crises than the generations before us did. So we see it as something different. I think our fear of maybe reprocessing and having nuclear waste is hard to manage, but it's different than, somebody being 2 steps removed from nuclear bombs and weapons and atomic energy, right? So we view it differently, and our challenges are climate change, which maybe generations before didn't think about. So I think it's coming around differently. I think depending on Congress, what they look like, maybe they'll shift and change too. Right now, not much is getting done in Congress. So I would say, until we solve this issue of what we're going to do with storage, or if we're able to reprocess, that's the biggest thing. We have a lot more waste because we are not legally allowed to reprocess, which would cut the waste in half. If we solve that problem, maybe then we can talk more about what we're going to actually do with it. We should do something more than just keep it on site. So I think the nuclear discussion is going to continue to rise until we solve these problems. And if we are struggling to get more stuff to market when it comes to decarbonized technologies, then nuclear is a known technology. And why don't we use Gen 4 instead of Gen 1, right? So that's easy. So it feels like it makes logical sense, but there are lots of kind of political hurdles we need to overcome first. And as we all know, those can take the longest amount of time. It might not even be the technology, it might be the politics that hold it up. So I'm super optimistic about it. I think there's lots of opportunity. So vote for somebody you think who's going to have the same views as you on that technology, because really the politics on nuclear is kind of what holds it up the most, in my opinion.
I can give you the pitch that I made to Shell about a small modular nuclear reactors. And we're talking about devices that fit on the back of a 18-wheeler, right? These are not large. That actually raises a concern that some nefarious party might back an 18-wheeler up to one of these and somebody in a neighborhood and pull it off and do a dirty bomb or whatever. So the pitch that I made was that there needs to be a customer who has a high demand for clean energy, resilient, small footprint, et cetera, who the American people would trust having a small modular nuclear reactor. Who is that community? Department of Defense. I think these things are first going to be deployed at defense sites where there are soldiers with guns on the fence surrounding it. And who are the best nuclear engineers in the world? U.S. Navy, right? The people who can run those are already in the Department of Defense. So I think the first growth opportunity will be in the Department of Defense. People will begin to become comfortable with it and see what it can do, and eventually then it will move out into community.
So I only have like a surface knowledge of the nuclear industry, but I do know that small modular nuclear reactors designs are being approved. Many have been approved and they will be built. So I think the short answer is yes. We're just kind of starting to dip our toe with new companies stepping into this space and new fuel source designs that are more resistant to theft and nefarious purposes. And then the addition of another design, which are micro reactors, these ultra small ones, which is pretty exciting to see that starting to kind of take shape. But I think we will. On the waste side, I think culturally we're really comfortable with generating a lot of waste. I don't know if you look at the landfills or drive near them, we had a pretty good arrangement with China, just shipping all our stuff over for a while, and they said, hey, stop doing that. So now here we are, we have, football fields worth of, radioactive waste that we need to deal with. And I think we will be generating more. And I'm not sure what the plan is for that, but I think it will come together.
Well, thank you. So I think I'd like to kind of use our last 5 minutes here to sort of make it a smaller scale question, like stuff we could maybe do at home or at a university. Some of this tech, should we be deploying some of this when we're retrofitting, or are we looking at all new redevelopments? And where do you go to find those opportunities? Are they in the Valley of Death?
No, they're coming out. As far as what you can do independently, I would say buildings are, I think, kind of like the quiet emitter. Nobody thinks about it. I think energy efficiency for years was the non-sexy energy, right? Because it's not actually energy, it's the lack of, it's not using it. But literally, this is the thing that's going to save us. And I remember talking to ACEEE, an energy efficiency group, who've been shouting it from the rooftops for like 30 years. And we're just finally now paying attention to it. When you're seeing it in energy outlook reports, people are like, energy efficiency is like this giant slice of the pie that we need to work on. And literally that's something you can do at the individual level. And it doesn't matter what community or group you're in. We heard from Energy Outreach Colorado earlier. They have programs. They will come into your house. They will do an energy audit. They will get it cleaned up. If you are a business, there is plenty of like incredible technology out there for HVAC systems, for cooling, for if you're doing data warehouse management. There's all sorts of technology out there, but you do have to be a little bit more proactive out there to look for it. Excel has programs. Literally, they can't get rid of, they are mandated by the federal government to spend that money. So oftentimes they'll have warehouses of LED lights that they can't get people to come and get. But oftentimes you just don't know it, because I'm not opening an email from Excel because it just means I owe them money, right? I'm not going to do it. So, I mean, there are programs out there. It's just, we're struggling to communicate out how to do that. So I would say, just literally type into Google, how can I make my home more efficient? Are there programs in my area? There is a program in your area, because all of our utilities, whether you're a co-op or a IOU, that you have to, that they have to participate in. So you can do that at an individual level. I would say if you're interested in climate, there's tons of fellowships, there's tons of internships, there's things that we do at NREL. I would just encourage you to go and look and do. And if you're an investor in the room, I would look at this startup technology that's out there when it comes to retrofits and buildings. It's phenomenal what we're able to do. We've just got to get over the last hump, which is more demos, which is more pilot projects, so we can get this stuff to commercialization.
So the quickest thing we can do today in our homes, energy efficiency is a huge one. And I do need to point out the efficiency paradox, right? Where the more efficient a technology becomes, the more we use that technology. So there's a balance there. But I think if you don't, okay, I have to give this example, right? So refrigerators started in the 30s and they were really inefficient, so they were small. But as the efficiency grew, so did the size of our refrigerators. We're using the same power that we did in the 30s to power the larger refrigerator. So that efficiency didn't buy us anything in terms of carbon footprint. But in our homes, you're going to look at your local power provider, your local municipality, and any other local nonprofits that may or may not have subsidies to help. You need to also seal the building envelope. You can save a lot of money and a lot of carbon if you seal your building envelope, making it more efficient in terms of heating and cooling. And then your own personal lifestyle, right? So every time you get on a plane, that's a massive carbon footprint. I kind of had a little guilt driving up here. I was like, I don't know, is this 400, 500 pounds of carbon I just put in the atmosphere? but I'm so happy to be here. And gosh, if I had a final word, I'd just say, let's go Nears. All right.
Yeah, I'll just add on the geothermal space, anytime you build a new building, you should be thinking about geothermal, whether it's a home, a campus computer science building or whatever, the economics of it are more than break even. It's a really good opportunity. However, I think this starts to get into some of the economic justice things, right? People who don't have the economics to have the footprint to lay out a geothermal closed loop in their front yard, it's not going to happen. So I think that there are some equity issues here, no doubt, but each of us should be doing what we can do when we can do it. So if you can do it, go do it.
Awesome. Thank you guys very much. I'd like to take this opportunity to thank our amazing panel, and I think Jessica has some closing words as well. So thank you guys very much.
Wow. As we close today, I genuinely stand before you with a heart full of gratitude and a mind brimming with inspiration. Today has been a testament to the power of collaboration, dialogue, and shared aspiration. I am profoundly moved by the depth of our discussions and the genuine commitment that each one of you has shown to understanding the intricacies of our changing energy landscape. The diverse perspective in this room illuminate our path, reminding us that the true progress is best forged through a variety of ideas, experiences, and aspirations. Our commitment to collaborative leadership has been evident in every conversation and interaction. We have not only elevated our own understanding, but also set a precedent for future discussions in the realm of energy transition. I want to express my gratitude to our distinguished speakers, panelists, and moderators who shared their expertise, insights, and enriched our collective knowledge. We are so thankful to every participant, both in person and online, for your active engagement and thought-provoking questions. Your contributions have been invaluable, shaping the depth and breadth of our conversations here today. Furthermore, I'd love to acknowledge, and I really want to acknowledge the importance of these discussions. The insights shared underscore the vital role we all play in preparing the next generation for the challenges and opportunities that lie ahead. By fostering education, encouraging innovation, and promoting inclusivity, we can ensure that the energy sector continues to be a source for meaningful employment and growth for future generations. In closing, I want to express my heartfelt gratitude to the organizing team, the volunteer sponsors, and everyone who contributed to make this event a resounding success. Your dedication and hard work have created a platform for meaningful dialogue and transformative thinking. As we part ways, let us remember that the challenges we face are significant, but so too is our collective determination to overcome them. Together, we can elevate not only the energy sector, but also the communities we serve and the world we share. Please today, after this event, let's keep the conversation going. Your first step in doing that can be in the ballroom next door, joining us for some drinks and appetizers starting at 5 p.m. So I think we're right on time. We'll move the event over to the North Ballroom just down the hallway. Thank you again for your passion, your insights, your unwavering commitment to affordable, reliable, accessible, clean energy future for all. Thank you all for being here today.